Okay, guys, beginnings of our derivatives unit. This is probably the cornerstone of calculus. Uh, Limits lead into derivatives, and and this will be a fairly big unit for us in this unit and in the calculus this year. And there'll be quite a bit of marks in there, as you can see when you look at the unit overview that we have. Okay, and you probably noticed that I'm redoing the derivative unit. Uh, Even though I think the limits unit and the very beginnings unit I did in 2018 or something like that. This is 2020, so I'm going to update a few things. There was a few errors in my derivatives unit that I made in notes, like negative where it should have been a positive and things like that. So I'm just correcting all that and making a uh, fresh video of that. So I want to keep these in about that half an hour to 35-minute range. So what we got to do today for derivatives is we're going to first of all look and review line slopes and line equation, slope equation, what that means and how we're going to use it. What are tangents and secants? And then we're going to use those two concepts to do some examples of finding a secant and a tangent to a curve. So basically what a derivative is that slope of a tangent to a curve at a particular point. And that's what we're going to start by doing a little bit of approximation type work in this area. So let's start off with reviewing a couple of things. So let me get to my marker here. And let's get this set up so that it's right centered here. Here we are. Okay, so we'll start off with slope of a line, we know. Okay, so if we're doing slope of a line equation, we have slope equaling m, and it's just y minus y1 over x minus x1. Okay, we're at y and y1 and x1 are 2 points on the line, and m is the slope. Okay, if we rearrange this, it can be rewritten by multiplying out x times minus x minus 1 to m equals x minus x1 equaling y minus y1. So this is called the line form here. Okay, that's grade 10, way back, a while back. Okay, slope of a line. Okay, and we have the equation of a line in slope-intercept form. Okay, if we have y equals mx plus b, this is the y-intercept. Okay, and that's a slope. This is a slope here. Okay, that's the y-intercept form of a line equation. Okay, and that's both grade 10 stuff. Okay, so let's move on to what a secant is. So if we look at secants, okay, a secant line. Okay, when we look at that, it's a line that intersects a curve at 2 points. Okay, so if we're looking at that, and we're going to draw a little graph here. So if I make my curve like a quadratic equation like that, and if we take a secant line is a straight line, I guess it would have arrows on both ends. Let's go back in here. Okay, so this would be our secant line here. And it would connect that curve in 2 points. So that's what a secant line. Example of finding a slope with the secant line is what we're going to do. Okay, first, so we'll do secant lines, then we'll do tangent lines next, because tangent lines are what we're going to be looking at, secting at one point rather than two. So we'll do a quick example of this. So example of finding the slope slope and line equation of a secant line that intersects a curve. Okay, so that's what we're going to do. So we're going to say find the linear equation and slope, we'll say, of the secant line see what I got in my note here, that intersects the curve the reason I'm updating some of this stuff here is when I made it a couple years ago, like I said, I made a few errors on it and things like that. And I also, Desmos has improved over the last 2 years. So there's a few more things we can do on it. Okay, let's say y equals, or f of x, if you like, equals 2x squared. Okay, so let's square that. You got to click up here to get that. Okay, 2x squared. Okay, at, I got to turn it back off here. At, let's say, x equals 1 and -2. Okay, so -2, and then it's going to cross in two places. So let's do a quick little sketch here and follow our process. I got lots of things open on the bottom here. Let me just, for some reason, I can never get that thing to shrink off here. Let's see if I can shut it down. Turn Eden off here. There we go. That's what it is. He was chatting me up earlier. Okay, so let's go here and let's do a little quick sketch. So if I take my marker and I make the curve, okay, this is a parabola because it's got an x squared term in it. So we don't have to make an exact copy of it or exact graph of it. So let's draw our little graph for 2x squared. Something like this. Okay, and then we're going to have our secant line going through here at 2 points. Okay, and it's going to intersect here at -2 and something, and here at 1 and something. Okay, so the first thing we're going to do is find the value of each point. Step 1. Find y value of each point of intersection. Okay, so you can do with me or whatever. So it's pretty simple. We just substitute y equals 2 times -2 squared, which would equal y equals 2 times 4, which equals 8. So we've got 2 and 8, or pardon me, -2 and 8. And then the next one is with 1, so y equals 2 times 1 squared, y equals 2. So we've got a 2 here. So it's not an accurate diagram. It would be up here and then sliding down like that. So this one should be a lot higher than this one. That's 2 high and that's 8 high. So be up here somewhere. But it's still going to work. Okay, then what you do is you find slope in the second step. Find the slope of the line of the secant. So we use the slope equation, y equals m, or y equals m. I was going to do the line equation there. I'm jumping ahead of myself here. So slope m equals y1, or y, let's keep it the same way I had at the beginning, y minus y1 minus y1 over x minus x1. So let's call this one x and this one x1, y1. And this will be xy here for now. So go ahead, put it in 8 minus 2, okay? And make sure that you're using the same x here. So this will be negative 2 minus 1. So we get 6 over negative 3, which equals negative 2. So now that we have our slope, now we're just simply going to calculate the line equation by using the slope-intercept form of this and plugging in the numbers of 1 point and leaving 1x and 1y blank. So that's our final step. So then we find our line equation. Okay, so when we're doing that, okay, we'll move it up here. We're going to write this in slope-intercept form. So line form, the slope equation in line form says x minus x1 equals y minus y1. So now you can choose either of the points. I'm going to choose the point negative 2 and 8 for whatever this one here. So slope is negative 2 times x minus negative 2. I'm choosing this point here as my x1 for this one. Could be the other point if you want to use that one. That one works too. Okay, and then I've got y, remember leaving one blank, minus 2. Okay, so then I've got negative 2x. Well, I guess I should do this step by step so I don't make a sign error, which can happen. So we've got negative 2 times x plus 2 equals y minus 2. Okay, then we've got negative 2x minus 4 equals y minus 2. Then we add 4 to both sides. So negative 2x equals, actually, y, yeah, we'll keep it that way. Add 4 to both sides, so that's mean plus 2. And then add 2x to both sides to get 0 equals 2x plus 2x plus y plus 2. Okay, that's standard form x, y, and then if you had it in another form, you could have y equaling something, okay? But usually they'll put it in this form, and usually they'll put the y first. They'll usually go 0 equals y plus 2x plus 2. That's called standard form where it's all equal to 0. Okay, so that's the first example that we did, and that's doing secant lines. Okay, and it's fairly simple. Okay, then the next thing that we want to look at is finding a tangent to a curve. So this is B part. I'm going to flip the page ahead. So that gets us into almost 15 minutes. So we're doing pretty good. If we go half and half here, we might go a little longer than a half hour. So B, this is going to be tangent lines intersecting a curve at one point. and they intersect the curve. At one point. Okay, and if we do that one, it looks something like this on our, if we have a parabola for our, say, a quadratic that goes up this time, we'll go like that. And if we were to draw a line right just touching at one particular point, this is what a tangent line would look like. And then, of course, we'd have an arrow on both ends for a line. Okay, so what you do if you look at this, if you're going to try to get a tangent line, so what you do is you basically look at, if I draw this bigger, like this, and say I want to get a tangent line here at point, let's say this is point B, and I want the tangent line here. Okay, so what I do is I take point A, and you can see if I'm drawing secant lines, and then I move it closer. Let's get my marker here again, and I move it a little closer to B, and I make another secant line. Okay, you gotta line it up a little better than that. There. Okay, guys, having some trouble. With my, there we go. My line drawing skills here. All right, so there we go, a little closer. Okay, and then I move it a little closer. So right here. And you can see that as I move closer and closer and closer, the slope of the secant line approaches to what the tangent line would be right here, as you can see. So I'll type that so it's written clearly. Okay, so if this was A here, and this was A1, and this was A2, and then A3 and A4, and you keep going closer and closer, we can say that as point A on the secant line, gets closer and closer to point B, the secant line's slope becomes closer to the tangent line slope. Or as like we like to call it in calculus, the secant line slope approaches the value of the tangent line slope. So we're going to do an example of doing this. And what we're going to do is we're going to take that and we're going to take the slope and then we're going to slide them closer and closer and closer and closer. We're going to slide that secant line closer and closer till there's very little separation between point A and B on the curve. And then that's going to be what we're going to figure out what the tangent line is approaching. So let's do an example like that. So this is an example of this is the last thing we'll do today. I'm going to do an example, and then I'm going to leave you with an example to do, and then I'll put a correction video that you can try because there's no real long assignment in this area. Okay, so we're going to be an example of finding the slope of the equation of a tangent line at a point on a curve. And you're going to need to know the slope as well. So what we're going to do is we'll do an example of that. So let's say find the slope of, I can't type, of, let's say the tangent line at x equal 1 to the curve. Let's make it a quadratic in, my example here that I have is a quadratic in vertex graphing form. So let's say y equals, I use y a lot, but some books will use f of x a lot. It means the same thing. X plus 2 all squared plus 3. Okay, and let me get that squared up in there. And then we'll do this particular one together here. Okay, so we know what the vertex is there, basically. And what we're going to do is we're going to just do a little sketch to keep this in our brains. If we have a little axis, I like to sketch stuff so I can see it because it just helps my head. Okay, so this is at -2 vertexes and 3. So it'll be -2 for x and then 3. Actually, you know what, my example, let's change this here. So I'm following my example here on my, that I made up. So I actually had this as a -2. So I don't want to deviate from it because, and then I don't have to do all the calculations in the calculator with you. Okay, so let's say it was a -2. So that means it's 2, 3. So it's on this side here. So if we just draw it, there's 2, 3. And then she goes up like this. And we want the slope of the tangent line at x equals 1. So right in here, this is 2. So 1 would be right close to it, right about there. And we want the slope of this tangent line. So the first thing we're going to do is we're going to, if you actually plug in what your 1 is, you can get the y point first. So you can get the y point there. So find the y point. Okay, it gives you an idea what it would be. So that would be y equals 1 minus 2 squared plus 3. This is going to give us a -1 squared plus 3, which is 4. So we know that this is 1, 4. That's the point where our tangent line is going to touch. Okay, so we're going to approach it from the left and approach it from the right, and then see what the slope is going to be between them. Okay, so we're going to do an approximation of slope. So we're going to approach and get closer and closer. So let's approach from the left. Let's approach from this 0.9 and then get closer, 0.99 and then 0.99. So step 2, that was 1. Step 2, approach x from the left. Okay, so that would mean if I take this, x equals 0.9. Okay, so I'm going to come from the left towards the 1. So if I plug in 0.9, I get y equals and you can do this on your calculator. This is why I wanted to 4.21. Okay. And then if I go here, x equals 0.99, I get y equals 4.0201. And if I go from here, x equals 0.999, I get 0.0, or sorry, not 0.4. I can't read my own writing over there. Sorry about that. Okay, 4.0020001. Okay, so there we have, as it approaching from left, it's getting closer and closer to that 4 mark. So now we're going to approximate the slope between those two. Okay, now can you approach from the right? Yes, you can too. So it doesn't matter which way you go, it'll give you, and then we're going to do a calculation. Now I've done 3, and 3 should be enough. So now we're going to calculate the slope. As we approach x, point A, we'll call it. Okay, let's call this point A here. All right, so let's do that. So the slope equals y1. So let's use this as our y1. 4.21 minus, and this is our other point, 4 over 0.9 minus, what is the y there? 1. Sorry, the x there, not the y. Can't read my own writing as usual. Okay, so this would be 0.21 over negative 0.1. Okay, so that's going to give us negative 2.1 for slope. Okay, so let's get a little closer. 4.0201, subtract a 4, and then 0.99, subtract a 1. Okay, so this is going to give us 0.0201 all over 0.01 negative. If we calculate that, we get negative 2.001. You can already see a pattern. I'll do one more because I put 3 of them up here. Okay, so all we're doing is we're getting very, very close to 1, but not exactly 1. So that which is our point here, and that's what we're doing with the x and then the y, and then calculating the slope. So this was 4.00201, and this would be minus 4, and this would be 0.999 minus 1. So if we do that, we get 0.002001 over negative 0.001, and that gives us negative 2.001. Sorry, I had this one here with an extra. I read the wrong one. This was 0.001. Okay, my mistake there. This one's 0.001. So we can see that the slope is approximately negative 2. Okay, as we get closer. Now, you can probably get away with just kind of doing the first one on either side of it and see if you get the same thing, like plug in a 0.9999 and then plug in a 1.0001 and see what you get. And if they're equivalent, then good. But most calculus people will show you as you approach so you can see the pattern coming out. But that's how you can approximate the slope. So once you've approximated the slope, it now becomes the same thing that you would do for the line equation now. You'd plug it into the line equation. Plug the point and the slope in. So now we plug in the point. Final step, plug in the point that you're finding, the 1, 4, and slope. Okay, and then, so if we write the equation, it's y, or m times x minus x1 equals y minus y1. So in y1 and x1, we'll put the point 1, 4, and we'll put the slope -2 here. So x minus it's minus 1 because it's 1, 4. I was going to put like that equals y. This one is minus 4. Okay. Now, if you rearrange this, -2x plus 2 equals y minus 4. Okay, it doesn't matter if you put these points in the beginning as well. It would still give you the same idea. Okay, and now we'll move everything over to the left. So we're going to add 2x and subtract 2 from both sides. Okay, so then we got 0 equals y. Okay, and then plus 2x, and then minus 6. There's our equation. Okay. Now, if you flipped everything over to the other side, it would also be right. So if everything was over here, it'd be -y minus 2x plus 6 equals 0. Doesn't matter. So they get both the same equations. Okay. So that's it for the lesson today. Those were the main things I wanted. I'm going to leave you with one to try, and I'll pop up a 5-minute video of me doing the solution, and you can check that as well. So what I want you to try is just find the slope of a tangent line, or find the equation, pardon my French, of a tangent line at x equals 2 for the equation at the curve, or on a curve. I don't know, let's go with y equals, let's make it simple, x squared minus 6x. Oops, minus 6x. Okay. Plus 2, if I put a 2 in there, I don't want to make it 2. It'll be 4 and -12 plus 4. Right. Okay, so I'm going to stop the video there. I will do that solution and put it right underneath this video. And that's the end of day 1. So good. Next day, we'll get into day 2.